tell me what all those side lengths are for a 30-degree triangle if I give you one of them, right? But it doesn't matter. What we should know, anyone remember sine 30 degrees is? A half. Very good. Glad some people are listening to me. Okay, so that is, and then this side was the root 3 if you remember. Not important at this point. What I'm trying to show you is, in a scenario where we have something like, I don't know, let's say this is 10 and that's 20, we're now going to calculate what this angle is. Now, we should know for this one it's 30, because any trig ratio that has sine of some angle equaling a half, that angle is always going to be 30 degrees. So we could have another triangle where this might be 0.5 and that's 1, or whatever. That angle will always be 30 degrees. Now we're going to learn how to use our calculator to work that angle out, because most of the time they're not going to be nice and exact like that. There's only a handful of exact trig ratios. So what do we do to do that is the question, and that's what this preamble at the start is. We've got to think of undoing, that process of undoing. So we should know that when we undo a plus, we use subtract. We use the inverse operation. When we undo a subtract, well, no prizes for guessing that's a plus. When we undo a times, what do we use? Divide, and vice versa, right? So the question for us is, we've got to undo a trig ratio. Not that straightforward. You can't do a times or a plus or something because you've done a trig function. You've actually done a sine to an angle. So we've got to undo that sine. How do we undo a sine? Well, the calculator does it for us, actually. So we use this sine to the -1. It's a pretty cool idea because, you know, how do you undo a times an x? Undo it by dividing by x, right? Or dividing by a number. When you divide, you're essentially raising that to the power of -1. So sine to the -1 is how we undo sine. What I mean by that is, sorry, let me explain that -1. I didn't explain that very well. Like 1/2 is the same as 2 to the -1. So undo that idea of timesing by a half, timesing by 2 to the -1 or 2 to the half is the same. There's a bit of a connection there. Where does that sine -1 come from? On the calculator, you should be able to see it on top of sine, cos and tan. And we access it by doing using the shift button. So if I want to go undo that sine of 0.5, you should all know the answer. What's the answer going to be? 30. Shift sine, put in your ratio 0.5 or the fraction, because it's going to end up being a fraction. Close the bracket, equals, and there's your answer, 30. So when we're solving that equation, to get the variable on its own, we've got to undo the trig bit whenever we're solving for an angle. So it'll either be sine, cos or tan. Yes. Okay, you're in the wrong mode. I'll fix it up in a minute. All right, have a go at practicing those few. I'll give you a minute or two. In reality, what happens with these questions is that you'll set up a ratio. That ratio is a fraction, but it could be a decimal. We always can convert fractions to decimals and vice versa. And so it would set up as an equation like this. Tan x equals something, a fraction or a decimal. You can see that next example, it's a decimal figure. The one under that is a fraction, but it's still shift tan, and then we stick in that number. So we're undoing the trig function part to come up with the value for x. Just like we undo, it is an angle too, by the way, so should have degree sign. So I'm just going to do the next one and then we'll move on. Shift cos, undoing the cos to get x on its own. That's kind of how you can think of it, 0.5150. And we get 59 that's 59 to the nearest degree. Oh, it says to our decimal place, so 0.0, that'll do. And the other ones are done in the same way. I just want you to try one. Actually, if I had in hindsight, I forgot. So let's do this one. Sin x equals 1.2. Can we do it? Go, shift sine, 1.2. What do we get? Uh-oh, math error. Why? Why is that working? Why is that working? Who was listening to me last week? Elizabeth was. Someone else first? Yes, you've got a good excuse. Who was listening to me last week? Who was here? Most of you were.
We pressed the clear button.
Why is it an error? No. No, doesn't matter. I didn't close the bracket. I'll do it again.
Because isn't it always like it can't be over below 0.
It's got to be below a fraction below 1. Why? Why does it have to be a number below 1 for sine and cos only? Yes, because the hypotenuse for sine and cos is in the denominator of the fraction. It's always the bigger number, so the opposite or the adjacent side cannot be bigger. That is not the case for tan. Opposite or adjacent sides can be as big or as small as we like. But for sine and cos, because it involves the hypotenuse, those sides there have to be the biggest. They go in the denominator, so the numerator can't be bigger. Hence, you can't have a number bigger than 1. Doesn't make sense. Okay, good. Someone was listening. Let's keep going. So then this next one, again, you can appreciate where we're coming from now. Here's now your fraction. You could treat the 7 and the 15 like adjacent and hypotenuse. How do we solve for the angle? So we write it like this. This is how I usually do it. So cos of theta is 7/15. So theta is the inverse cos of 7/15. You don't have to change that to a decimal. You can just go shift cos. Oops, let's get rid of the error first. Shift cos. And if you want, people like to write this as a fraction bar using the fraction, which is okay, but tap out and close the bracket, otherwise it won't like it. And there we go. 62 point to a decimal place, so 0.2 degrees. So we undo the trig part to solve for the angle. That is it. That is all we do with our solving for trig. The two possible sides, numerator, denominator, or the angle. All right, keep going. And then, of course, these ones with actual triangles should be then more straightforward to you. I'll give you a few minutes to work on those. Just practicing the skill. So in the triangles, the first thing, so if you like, I'll put the steps here. The first thing you need to do is you need to decide on the ratio. That's probably the hardest part in all of this. Everything else works in a similar way. So you decide on the ratio. Then you need to set up the equation. Now, in general, that equation would be either finding a side length or finding an angle. For these ones, obviously, the equation involves finding an angle. Then you solve. So if you're finding a side length, so if it's a side length and numerator, then you need to multiply by the trig part. If the side length is the denominator, I don't know if this is helpful, but you divide by the trig part. I don't want you to memorise processes. You've got to really understand what's going on here, though. Or if it's an angle, then we've got to use the inverse trig part. So either sine -1 of whatever the fraction is, or cos, or tan, whatever that fraction is in the question. So for all of these today, don't worry, we will mix them up for you. But for all of these today, that is finding angles. And so it is essentially set 3 until we get to some of those harder triangles. but certainly for these ones. And so with this first one then, we need to decide, is it sine, cos or tan? Put in opposite side, hypotenuse, it's sine. So put in what we know, sine of the angle is 12 on 19. Undo the trig part, inverse sine. We're solving for an angle. Make sure you tell me it's an angle and not a unit. Don't give me the answer in centimetres, it is degrees. So inverse sine, shift sine. The good thing is it comes up on the calculator as sine to the -1 to remind you. Close the bracket, equals 39.17 degrees here.
Do we always have to put that little -1 in?
Yes.
How do we do that? Just put
Shift whatever the trig is, part is. Otherwise, if you don't, you're not solving for an angle. Next one, here we've got opposite and adjacent. So the trig ratio is tan. That's step 1. Decide on the ratio. Step 1, it's tan. Tan, set up the equation. Tan x is 23 on 32. Solve. Again, it's 3 part 3 because we're solving for an angle. So x has to be inverse tan. Whatever that is.
Why
Yep.
inverse tan here, but in the recap we didn't?
Because in the recap, we hadn't done solving for angles. In the recap, we only did solving for side length. So when you solve for a side length, you're not undoing the trig part. You have the trig and you know the calculation. It's tan 15 or sine 30 or whatever it was that we were working with. Keep going, next one. This time we've got adjacent and hypotenuse. So it's cos. So cos -1, whatever that fraction is. $40.97 degrees. All right, keep going. Because it involves 2 triangles, so just separate them. Work out what you need and go from there.
Not finished either because we have to find X.
Yeah, not finished. Still got to find X, exactly. Yeah, I kind of started E, but then forgot that I hadn't done D, so I'm going back to D, but we'll fix that one up. So D, again, opposite over adjacent, so that's tan. Now, the other thing you might want to do, if you want to think logically, this is tan 37 on 11. So that 37, is a big number, so compared to the 11. So X should be bigger than halfway, should be bigger than 45. And you'll see that when we calculate it. Shift tan of 37, I know most students don't try and think to see whether their answer makes sense, but this is a good one. You can see that's 73 degrees. Why is it so much bigger? Because that 37 opens up, that angle opens up to a bigger side length. So if you think about it, you can try and do a bit of check to see at least if your answer makes sense. All right, E we didn't finish. I did say change that to an 8. We're only halfway through. With E, the problem with finding X is that you don't have enough information. Remember, in a triangle, we need 2 pieces of information in a right triangle to find a third piece that's missing, or find anything that's missing. So as it stands, this second triangle where X is, we don't have that information. We've only got the 8. So we need to use the 49 and the 14 to find that vertical distance K. I've called it K, you can call it what you like. So that then we have that second piece of information. So once we've found K, then we've got a new triangle. If you find it easier, just redraw it. K is now the hypotenuse. X is that angle there. And so we're doing cos. Try and keep that number to reduce the error to at least 4 decimals. Or even better still, keep it in your calculator. Yeah, you can just do inverse cos of your 8 divided by the answer. So x equals inverse cos of that number. So 40.79. All right, I think we've got a few more of those more challenging triangles. So this is really, if I have to be honest, more course 1 level. Everything we've done up to this point is really year 9, all courses. So these ones here at least challenge you a bit more. Just saying, and then of course a couple of worded ones, so I'll let you think about that. There's a bit of work to do.